So in this question, we are given an n by n 2D matrix representing an image, and we need to rotate the image by 90 degrees. And you have to rotate the image in place, meaning you have to modify the input 2D matrix directly and not create a completely new 2D matrix and then do the rotation. So here you can see that we have the original matrix and all the values are rotated 90 degrees accordingly, including this one. The 5 goes all the way to the end, and the 8 goes down 1, 4 goes over, 3 goes up, and 6 goes over. So in this case, what we first have to do is we need to transpose the matrix. And to be able to transpose the matrix, first we need to determine the length of the matrix, which is n, and then loop through the matrix like so. Basically, we want to swap the positions in which they are at the row and column position to the column and the row. So for 1, for example, the row and the column is 0, 0. The column and the row is 0, 0. And if we swap the two, it will remain in the same position. For 4, the row and the column is 1, 0. The column and row is 0, 1. So then what we'll do is we'll take 1, 0, put it into 0, 1, and swap like that. So what we basically get when doing that is we have matrix at I, j, and matrix at j, I, equals matrix at j, I, and matrix at I, j. And when we print this out, we basically get the transposed matrix here. Now one thing that you can notice is that for each row in the matrix, you can see that it's basically just a flipped version of the expected. So instead of 147, you have 741, 258, 852, 369, and 963. So in this case, a simple way to do this is we can traverse through all the rows and reverse them accordingly. So we have matrix at I would then equal matrix at I reversed. And this is an annotation to basically reverse an array. So if we run this, you can see that it appropriately reversed the array for each section here as well and gave us the expected output. When we submit here, we get the correct answer, and it is very time efficient with the time complexity of O of n squared, since you're traversing through the entire array first, then flipping each row. So just to reiterate what we did, we first went through the entire matrix and transposed the various values by swapping them with the row column and column row positions. And then we went through the entire matrix again for each row, and we just flipped each row accordingly to get the rotated matrix.